Oh wait, no, that's Omri. That's this is Modular Curiosity. Sorry, wrong voice. Hey guys, welcome to Modular Curiosity. Today we're going to be looking at the Macro Oscillator 2, also known as Plaits. Now, there have been other videos, including by Omri, that go through every single feature of this. I just want to touch on some of the really cool, special, weird things that make this oscillator different from other oscillators in our stable. So let's go look at that right now. So this is Plaits, or the Macro Oscillator 2 from Audible Instruments. Now, as we know, Audible Instruments modules are actually the VCV Rack version of Mutable Instruments modules. And so if we go to the Mutable Instruments Plaits manual page, we can see everything we need to know about this module. All right, that's it. Good episode. Talk to you later. No, of course that's not it. No. There are some really cool hidden gems in here. Some neat stuff. And particularly, I'm going to go through these knobs here, the F knobs, and a really cool and unusual thing that happens in the interaction between input 1 model and input 3 trigger. There's some really interesting things that happen here. Let's go check out what I'm talking about. So I have a pretty standard patch here. I've just got my MIDI from my keyboard. Coming from here, and simple stuff. Gate goes to trigger, CV goes to Fulch per octave. Now already this is different from a standard oscillator, because normally wouldn't you have to take an oscillator and use the gate and go to an ADSR, have the ADSR drive a VCA, have the VCA turn the note on and off. So to get any kind of response from our keyboard other than a constant slew of notes, we'd have to go through all that. We'd have to do something like this. And here we go, something along these lines. And so notice we've got a typical oscillator moving into an ADSR. The ADSR typically builds our attack sustain, or attack decay, sustain release into a VCA and turns it off, because right now, if we didn't have that, this would be on all the time. We use the ADSR to basically turn the note off when I'm not playing a keyboard or not sending a trigger or a gate. However, let's turn that voice off and turn the Meta Modulator or Meta Oscillator on, and you'll notice that it has a trigger input. And so all of this is built in. So by using the trigger, we already have that, because, hey, if you're going to control it from a keyboard or sequencer or pretty much anything else, this little trio of modules is pretty much your standard build. So why not build that right into here? Now, it doesn't give you the control of your ADSR the way that this does. If we took trigger out, it's always on, just like a regular oscillator. But what's the other thing that we tend to do? We tend to take another ADSR and a filter and then make it do things like go yow, wow, 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 right? Well, check this out. If I don't have anything jacked into the timbre input, listen what happens. Hear that? It's kind of like a filter. But if I don't have anything jacked in here, the attenuator of the inverter, instead of being an attenuator with nothing being sent to it, it actually becomes a low pass gate. And listen to that. So what this is doing is telling us, do we want to sweep from a high note down on the timbre? Or do we want to sweep from a low note up? or I should say low timbre and up. So if it's on this side and the negative side, every time I hit the key, it's basically like doing this. And if I'm on this side, it's kind of like doing this. But notice I don't have to actually move this. Already, that's kind of cool. But check this out. Morph, which has different functions based on what voice we've done, kind of does the same thing. So if I turn it to the right side, in fact, let's take timbre out. See, so we're basically having an ADSR and a VCA built into this knob to move this morph knob or move the timbre knob without having any of this being built in at all. It's already built into the oscillator. Really cool stuff. And the harmonics, morph, and timbre change what they do based on the voice, which we would expect. Really cool stuff. So try playing with the macro oscillator without any ADSR or VSA on it. Use these knobs and see what kind of interesting things we can come up with. And go back to the manual. And with each voice, check out what the timbre and morph do for each of the different voices, because every one of these is modified by those knobs. But there's some more really cool stuff. For example, right here in the wavetable oscillator, see interpolated and not interpolated? Okay, what does interpolated mean? Okay, so interpolated, and it's strange. I actually use this at work with a particular type of database where we have data points, but we don't want to have to fill up a database with, say, data points at every second of when a wind turbine is turning, or for every second exactly how much kilowatts is a solar panel providing, or a hydraulic plant producing from kilowatt or actually megawatt minute by minute by minute, or even second by second by second. So what we do is we measure it at a point in time, and then as long as it's staying within a particular error boundary, we don't write a new point to the database. And then if it moves beyond that boundary, we put another point. So what it does is, let's say we have a point here and a point here, but we don't have any points in between. What it does is it interpolates, means it runs this simple y equals mx plus b formula and determines, okay, if I have a point here and a point here, that means the slope of this line looks like that. And so at this point, at this particular x, it's going to have that y. Now that's interpolating. If you're calculating every point along this line based on data points on either side, that's called interpolating. If you did not interpolate, this would be flat. It would just come, and then it would jump to here, and it would be flat, and then it would jump to the next one. What does that mean in the context of music? Well, it means that if we're on the right side in this wavetable on the harmonics, we have non-interpolated. So listen, you can actually hear the steps. And for each one of those voices, say, let's pick this one, we have different timbres. And they are also stepped. But if we go to the left side of harmonics, they are now interpolated. Hear how smooth they are? Which means I can now take, say, an ADSR, move it here, turn my attenuator up, and say I want to sweep through my timbre. How about... There we go. And so I'm basically using this timbre sweep through the wavetable as if it was a filter. So that little Joe, 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 which I would normally do with a filter, I'm now doing by sweeping the timbre. What if, however, I do the same sweep in the non-interpolated side? Well, you hear the steps, which is a cool, different sound that we might be looking for. Really kind of cool. What if we did the same thing with the Morph? Who knows what's going to happen? In fact, if we want to be very strange, let's go ahead and put an LFO on the Morph. So we're morphing through different sounds as we're playing, and the timbre is doing a non-interpolated sweep on the filter. Really interesting different sounds there. Stuff that we don't normally get out of a normal oscillator. But now let's move on to the next one, chords, because this is so cool. This chord is awesome. As we go through the harmonic sweep here, right now it's, let's see. Right now it's just octaves. If I scoot it up, we're going to get an octave and a fifth. Now, we've done that before with multiple oscillators. Remember how we take our tune because we know that this goes a fifth that way on the even VCO, or we'll tune it to fourths, and we get a really cool sound where we have a harmony going through one key on my keyboard, actually produces multiple sounds, multiple pitches. But over here, we can build those multiple pitches within a single oscillator. Once again, we're getting rid of a whole bunch of other modules and just using the features of this. If we keep going on the harmonics, the next one is a sus4, let's see, octave, fifth, sus4. So what we've done is we've taken that second harmony and gone from a fifth down to a fourth, down to a minor third. And now we're going to add a minor seventh and a minor ninth, minor 11th, 6/9, which is going to have a major sound. And notice we just went from minor, major, major ninth. Ooh. Major seventh, very jazzy. To our straight on major. the timbre, now this is what's really cool. Let's grab something complex like a minor ninth. What this does is it goes through voicings of that same chord. Let's add a little more reverb in here and make that sustain for a bit. So, of course, what if we modulate that? Really cool stuff in there. Interesting things to play with. How about now the whole right side of this is drum sounds and percussion sounds. That's probably worth an entire other episode. But the part of the manual that just struck me and thought, oh my gosh, are you kidding? Is this. So is this little note and this little bullet point. Note that when the trigger input 3 here is patched, model changes only occur when a trigger is received. What? Okay, what are they talking about? They're talking about how I could change these buttons. You know, the way I press these buttons, that's CV controlled. No problem. Let's go do that. Okay, so I've just used the dual attenuverter just to give myself a voltage. And as I slowly turn this, we can see that I'm actually going to move through these voices. But what about that cryptic little note in the manual? Let's look at it again. Note that when the trigger input 3 is patched, modal changes occur only when a trigger is received, or trigger input 3 sample and holds the value of the model CV input. Sample and hold. Okay, that means that if we are varying this, it means it will only change modes when I hear a trigger, or when it hears a trigger. So if I start playing, now that's kind of an unusual technical thing of why would I use that? I mean, it's kind of interesting. Okay, it'll change modes, but not until a trigger hits it. Well, what happens is this. Okay, so I have a whole bunch of sample and holds over here. What I'm doing is I have a clock going to a sample and hold. So this particular sample and hold, every time it's triggered, it gives me an output. I'm using my offset and my attenuverter to limit how far. So if I'm trying to limit it so that I'm only on the green side. Now I'm going to open it up a little bit. And see what's happening is every time this clock hits and it triggers, wherever this randomly happens to be on this side, it will change the mode, but it will only change the mode when it hits a trigger. So I could have an LFO on this side and it will hold it until it hears another trigger. That's kind of an interesting idea because I could do the same thing with, say, the timbre. And I could do the same thing with the morph. And you know what? Let's add another one. Yeah, I'm not using that. Let's go to Harmonics. And what if we add a drum? And now with this attenuverter, the offset and the span, I can move it from the green side over to the red side. Or I could open it up so it'll span both sides. And all of that sound is coming from a single oscillator. Drum solo. That's just a heck of a lot of fun. But I want to show you one little cool thing about this. Okay, in this last green mode, we have these weird vocal sounds, but they're not just vocal sounds. There's some actual words in here. So first of all, let's check this out. I'm not going to change the frequency with the keyboard. I'm just going to trigger it. Now the timbre changes the voice of the voice. So let's use about here. And Morph will sweep through the wavetable. But as we move through the harmonics,
Yellow, red, 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 orange, yellow, green, indigo, violet, violet, indigo, 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 blue, green, yellow, orange, red.
how cool is that?
Red. 1, 1, 1, 2, 4, 3, 4, 4, 5, 6, 7, 8, 9, 10.
Move a little further.
3, H, A, D, F, I, K, L, M, Q, R, S, U, V, X, Y, S.
There's the alphabet.
O, 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 K, Kilo, Alpha, Bravo, Charlie, Delta, Foxtrot, Hotel, Juliet, Mike, Oscar, Quebec, Tango, Whiskey,
Cool.
VCA,
But now, right at the end,
VCA,
we have synthesize your words.
analog, clock, control, electronic, frequency, generator, knob, modular, modulator, oscillator, patch, VCA, voltage, waveform, machine, generator, generator, filter, filter,
Let's go ahead and put that on a pitch.
filter, 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 knob, machine, modular, modular, generator, control, control, instrument, knob, patch, patch, voltage, voltage, waveform, patch, modular, synthesizer, filter, knob.
You just know that you want to patch that into your technical patch, right? Have a nice oompa, 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 oompa techno patch going with a synthesized voice saying cool synthesizer words in the background. Anyway, those are some of the cool tricks and not so much hidden, but just obscure little features of the Macro Oscillator 2. As always, if you like this video, please like and subscribe because that does help me out. And also, as always, stay curious. All right, see you next time.
Knob, modulator, waveform, VCA, sequencer, oscillator, voltage, VCA, waveform, circuit, frequency, generator.